on the circle, goes through the circle, and ends at another point on the edge. That's a chord. Endpoints are on the edge of the circle and it goes through it. When you have two chords, like so in this diagram, A, B, and D, C, when they intersect, they form angles, right? Here, there's an angle here, here, and all angles, there's four of them. Okay, and we can figure out the measure of these angles formed by those chords by just adding the intersected arcs and dividing them by 2. So that's what pretty much this little box is saying. It's saying that angles formed by intersecting chords can be found by taking half of the sum of the intersected arcs. There's a little more in depth here in this example. Alright, so we take a look at this circle. Which angle is congruent to AED? So this angle right there. Gary? Good. Angle CEB is congruent to AED. You can tell me why they are congruent. Gary, what's right now?
They're opposite angles.
No, they're opposite. You're correct. It's like a very... What are they? Very good. They're vertical angles. Okay. So, what two arcs are intersected by these two angles? Well, if it helps, go ahead and highlight. I'll highlight this angle. Okay. The arc that intersects it, it goes from one end of the opening to the other. So what arc intersects that angle? What arc is that? BA or AB, either one's correct. Okay, we'll do the same thing with that other congruent angle. That helps highlight. We have this angle right here. Start at one end of the angle, go to the other. Which arc is intersected by that angle? B.
Where's PA?
It's DA. So what's in there?
No, it's like a B. Well, now we can find the measure of angle AEB by taking those intersected arcs, and it said that the smaller arc is 58. Which one's smaller? By just looking.
Yellow.
Yellow one, AD. So we know AD is 58, which means CA is 76. Okay. Well, we can take those two intersected arcs, add them together, divide by 2. And we can find the measure of that angle. Right? What do we get when we do 58 plus 76? What do we get? 134. We add those together, we get 134. What's 134 divided by 2? 67. So we know the measure of this angle is 67 degrees. Which means this angle is also what? 67. Just for fun, how can we find the measure of this angle right here? Gary?
You take 180 and subtract 67.
Good. What do we get when we do that? 13. Good. Right? Gary is correct because these two angles right here, they're right next to each other and they fall on a straight line. So we know they add to 180. What's that special name for these? They sit on a straight line. They're supplementary is another special. Supplementary. Sounds like line. Linear pair. Yeah. So when you get a linear pair, so this angle is 113. That angle is also going to be 113. You might have to recognize that sometimes. Okay? So essentially all you're doing when you have two intersecting chords, so the angle's inside the circle, whatever angle you're trying to find, you take the arc intersected by that angle, and then the arc across from it, add those two arcs up, divide by 2, you have the measure of the angle. So you're trying to find the average of it. Questions over there? And when it's inside the circle, the two lines intersecting inside the circle, you add the intersected arcs, divide by 2. You have the measure of the angle. A line that we haven't talked about yet is a secant. We talked about tangents yesterday. How many times does a tangent touch a circle? Okay? Once. Right? How many times do you think a secant is going to touch a circle? Twice. Yeah, very good. So we look here, BC is a tangent because it's touching a circle one time. Okay? AB is a secant because it starts outside the circle, touches the circle, goes through the circle, touches it again, and then leaves. Okay. So the difference between a chord and a secant, a chord is everything is inside the circle regarding a chord. The end point's on the edge of the circle, it goes to another edge, and that's it. It never leaves the circle, like here. These lines never left the circle, they're all inside. A secant leaves the circle, it's on the outside. Okay. Questions over there? Okay. We can now use tangents and secants. You notice now the angle's outside of the circle.
So, good. So when the angle is on the outside, you do something a little bit differently. Again, this whole little section right here is whether the intersection's inside or it's outside. You can see we're talking about angle P. Obviously, angle P is outside the circle. So how do we find that angle? Well, it's actually a really similar formula to it. So it's outside the circle. It can be found by 1/2 the difference. Again, difference means subtraction. So instead of adding the two together, divide by 2, I'm now going to subtract them and divide by 2. Now, one thing is, this is what it's going to see here in a second. I know there's no numbers up here yet, but there'll be numbers down here in a second. But really what we're going to do is we want to take the larger arc minus the smaller arc. Then you're going to say, well, how do you know which one's larger? How do you know which one's smaller? Well, a lot of times there will be numbers on it, but other times you can just look at it and figure it out. So, of these two, purple and red, which one's larger? Purple. So I would do purple minus the red one, and then divide by 2, and that would give me my angle up here, which would be angle P. So these are the 3 different ways you'll see it. Right here, these are 2 secants because they go through the circle, touching at 2 points. The lines continue on. The next example, notice the formula is exactly the same for all 3. Not different pieces, but they're exactly the same. So over here, I have a tangent that touches at 1 point, and I've got a secant over here. So now we're talking about, this is my arc, the larger arc. This is the smaller one. And my angle is still angle P up here. The same thing. I would do purple minus red, divide by 2. That would equal my angle P. And the last one over here, these are 2 tangents. But it's the same exact thing. There's P, or A, excuse me. Now we have a major arc of ACB. We've got a little minor arc of AB. Still, the angle's on the outside, so we do the purple minus the red, divide by 2 to figure out what P is. So every time you do this, we're asking ourselves, is the intersection happening inside or outside? That determines whether we subtract them or we add them. So let's try these 2 examples here. Number A, intersection inside or outside? Inside. The intersection is right there in the middle. So are we going to add these arcs or subtract them? Add them. What we want to get in the habit of is to put the larger one first. Well, which one's larger, 90 or 46? 90 is. So we're going to do 90. Because they're intersecting inside, I add 46. And I'm going to divide that by 2. That'll be your answer. I'm going to simplify a little bit. 90 and 46 gives me 136 divided by 2. What's half of 136? 68. So I know that x is going to be 68 degrees. So it is. One thing we'll talk about more of, I just want to put this on your radar here, is this. When we're finding these angles, the angle is always in between the two arcs. So you're finding this angle and this angle. Because they're identical, because they're vertical angles. There might be a time where they ask you to find this. That will not be what you first get in. But we know that two angles side by side on a straight line will add up to what? Two angles side by side on a straight line, it'll be 180. So if I find what this is, I can then find what that other angle is. Down the road, we'll look more at that later. Looking at B now. Are they intersecting inside or outside? Outside. So we know we're going to subtract them, right? So on the outside, we subtract them. Now let's outline our pieces we have here. There's one. Oh. So what's the problem? What's the problem with this problem? What's the problem with the problem? Doesn't give us. Yeah, we have 45. What's the blue one? Not shown. So what? You can't do it because I have two variables. You got to exit that blue thing. Next question, Kaji says, I agree. But then you're wrong. I don't agree. Yes! What, you just make up numbers? Where does 180 come from? On a straight line. You're on the right. You're talking this line. It went through the middle, so it cut the circle in half. So this over here is a semicircle. The semicircle, of course, adds up to 180. So if I know the whole thing has to add up to 180, if I get rid of that piece that I already have, I'll have the unknown piece. So I'm going to do 180 minus 45. And that will tell me what it is in blue. 180 minus 45 is 135. So now, I know that's 135 for the blue part, 45 for the green part. Which one of those two is larger? That's an easy answer, so feel free to answer that.
The 135.
The 135 is, you're right. And because the intersection is on the outside, what do we do with these two numbers? Subtract it. So I'm going to have the larger number first. So we're going to do 135 minus, because it's on the outside, 45, divide by 2, and that will equal something, you're right. Just simplify a little bit, 135 minus 45 gives me a 90.
Equals 45.
Divide by 2, can I just cut it in half instead? 45 degrees. I will agree. Somebody's going to look up here and say this, and you're going to be wrong. Somebody say, wait a second. That small angle that's sitting next to the x is 45. Is that a shortcut? Every time that angle is sitting right by that little piece, it's the same value? No. It just happened to work out that way. There's not a shortcut with this. We're still going to have to subtract them, divide by 2. It just happened to be 45 and 45. It happens sometimes. Not very often, but it happens. So still do the process. Inside, outside. If it's outside, subtract them, divide by 2. That's it. Question though, it's pretty straightforward. Real easy formula too. Well, what if we have the angle? Oh, question, yes. Well, say again, what was it?
The 45
That is the arc. That's the smaller arc. So that's part of the circle. That's 45 degrees. The green part, yep, that's the 45. So think about a whole circle's 360. That's just 45 degrees of that whole circle. So the rest is, whatever the rest is, 320. Or 315. All right. Questions? Questions? What if we have the angle, but we're missing one of the arcs? Well, we can still solve it using the same exact formula. So here's an example here. We might need to find the arcs instead of having the angle. So we've got a diagram, we've got some information. What do?
Put it to use.
We put it to use. Sure, why not? So we draw it. We label it. We do whatever we need to. So arc AB is 65. I'm going to go ahead and mark that. So arc AB. Arc is right there. It's 65 degrees. Again, this is one where highlighters, colored pencils, this unit especially, really helps you visualize these things. I also know that angle E, which is over there, is 115 degrees. Too hot for my blood, but whatever. and we're asked to find major arc ACB. AC. That's pretty good tracing, guys. That's spot on tracing. I hope, recorder, you saw how sweet that tracing was. All right, cool. That's the red dot. So, is the angle on the inside or outside? Outside. Oh, yes, these are two tangents. These two lines are tangents. So it is on the outside. So we're going to our formula. Do we add or subtract when the angle is on the outside? Subtract. So I take the larger one minus the smaller one. All right. Well, the blue one's the larger one. Do we have any measurement for the blue one? No, that's what we're looking for.
We can find it out.
That's what we're going to do, yeah. So I don't know what it is. I'm just going to call it X. Why not? But I'm still going to do my same process. I'm going to do the larger arc, which happens to be X here, minus the smaller arc. What's my measure of my smaller arc? So I'm going to say minus 65. I am going to divide that by 2, because I always cut it in half. And this is going to be equal to my angle. Well, the nice thing is I already know the angle.
I have a question.
Yes, Kanaji.
Why don't we set 360 minus 6?
Hold that thought. Pump the brakes, hold that thought. We're going to go solve. I know a lot of you guys go through withdrawal because you haven't been able to do a bear problem lately. So you're welcome. Here comes one for you. So I want to get X by itself. What do I need to do? Multiply by 2. Yeah, that's the furthest thing away. That division's not so nice. Let's multiply by 2. Make it a little easier. It's a two-stepper. See ya. So X minus 6,5 is equal to 115 times 2, 2, 3, 0. So 230. Now we got a baby there. One last step. What do you want to do? Add 65. Add 65. Add 65. Add 65. Add 65. Here you go. X equals 295 degrees. And there's our answer. Now, Kanija, notice something. As probably some other people notice too. They're saying, wait a second, why am I doing all this work? What's a circle add up to? How many degrees is a circle? 360. If I know a circle is 360, the piece I already knew was 65. Can I do 360 minus 65? Yes, you can. That only works, though, unfortunately, for tangents. So if you have two tangents, meaning they touch the circle at one point, you can do that. That works out. That's a trick of figuring it out. But it doesn't always work, because sometimes you might have a tangent, a secant, or two secants. This formula always works doing that way. So if you have it like this, yeah, you can figure out, say, yeah, that whole circle is 360 minus 65, 295. We want to teach you the process, though. The process makes more sense here. So the outside minus, or the outside arc minus the inside arc divided by 2, set equal to the angle. Questions on this? Question? Question? Numero cuatro. All right, well, I got a diagram below. We want to find the value of x. X is not the angle, so it's not going to be real easy. I'm going to have to solve for what x is. You have to figure out what this arc is. Well, same exact process. I'm going to draw some of my diagrams so we see what it looks like color coordinated. Some festive like that. The angle I have is 35. So we ask ourselves this: is the intersection happening inside or outside? Inside. Do we add them or subtract them? If they're on the inside, we add them. Now, we want to get the habit of putting the larger arc first. How do you know which one's larger? It doesn't really matter, this one. I'm guessing this guy is a little bit bigger eyeballing it, so I'm going to say X is first. But if you put it the other way, again, remember, adding it doesn't matter. But if you do it and get a negative answer, you did something wrong. They should always be positive. So again, I'm going to add these together, divide by 2, set it equal to the angle. So I have an angle of X. Now I'm going to have to add the other angle of 30, and I add it because, again, they're intersecting inside. I'm going to divide by 2. That's what we do. And I'm going to set it equal to that angle that's in the inside. That angle happens to be, what's my angle on the inside? 35.
Say 5.
C. Just like before, we're going to go back to that bear problem. Solve. Very similar every time you do this. Got to get x by its lonesome. 30 is his best bud. 2 is talking smack. C at 2. Multiply by 2. Multiply by 2. Egal. X plus 30 is equal to, what's double 35? C. One stepper. I like Gary. X equals 40. Now, again, what I want you to get in the habit of when you look at your practice here in a little bit. When you solve for this, when they're on the inside, you are solving for these inside angles. There may be a question. You may see something where it says, I want to know what this angle is. Well, first you find this angle, and then you can easily find that one because you know those two angles are linear pairs. Subtract from 180. So make sure you apply that knowledge. Questions with those? Okay. And